Good morning, ladies and gents, wherever you are, whenever you are. We are putting our last two lessons together, already our last lesson, and we are writing what we call the standard form for parabolas. Okay, so maybe I'll just quickly remind you. Last year, in grade 11, our standard form was y equal ax squared plus q. Okay? And what we've done, we've learned the last lesson, is that extra p. It was, well, we didn't call it p, we said we looked at x plus 1 square or x minus 3 square, but we learned what the significance of this. So what does p mean? What does the p do? It's a horizontal shift, you're right. It's a horizontal shift. Horizontal shift. Okay? If p is larger than 0, let's say x plus 1, where are we shifting it? We're shifting to the left. That means it's a left shift. Left shift. If p is smaller than 0, for example x minus 2, then obviously it's a shift to the right. Right shift. Okay, so that's what we really added in grade 11. Okay? Just going to make sure you can see it. Sorry about that. Okay. Now, let's just put it here. Okay. But we mustn't forget the A and the Q that we already had last year. What does the Q stand for? What does the Q do? Vertical. It's a vertical shift. Vertical shift. Up or down. Okay. If, I'm not going to write it down because actually it's, well, let's do it. If Q is larger than 0, which way are we shifting? Let's say plus 2. We're shifting upward, obvious. If Q is smaller than 0, obviously it's shifting down. And that brings us, lastly, finally, to A. That's the only tricky one. We spoke about it. What does the A do? Okay, Jojo does that normally, yeah? Remember that thing, okay? So the bigger the A, the more squashed it is. The smaller the A, it goes like that. But if we're doing a negative A, what happens then to our parabola? It goes down, reflection, okay? So let's try and make that, right, like this. If A is larger than 0, we have a smiley face. If A is smaller than 0, we have a sad face. Okay? Okay? If A is large, or large A, okay, that means it's going to be squashed like this. If it's a small A, it's going to be nice, straight and narrow. Okay? So that's really worthwhile writing down, but even more important really is to go through an example. So I'll pause, let you copy that, and we'll move on. Okay, chaps, so what we're going to do is now apply this into answering question style that you get in the text. So I can give you a function, f of x. You know, normally I write y equal, but sometimes we call it f of x. I'm sure you've seen it before. Okay? For every x, there's a certain value. And we're going to do a lot of stuff with this function. First of all, just draw sketch it. Which we've done stuff like that. Well, we didn't do it with the vertical. We do the vertical separate and we do the horizontal, now combined together. So we got to always start thinking about your simple, what you call it, the mother function. The mother function y equal a, y equal x squared. Okay? Now, I would say, okay, by putting a minus 2, what am I doing to the mother function? I'm flipping it because I've got a negative, that's going to be a sad face now. Okay? So just in my head I know, okay, it's a sad face. It's a sad face now. I'll draw it. It's also because of minus 2, it's going to be a little bit more squashed. So it'll be, let's say, like this. Now you don't need to do that in the book. You can draw it if you want, but I tend to just think about it. But there's a certain process. So we start with a sad face. Now we've got plus 8. What does that plus 8 mean? Yeah? It shifts up. Okay? So I don't know, I think what I'll do, I will write it down. I will keep this like that. Okay? Alright, so now we shift this thing upward. I'll do it in a different graph, otherwise it's going to be too messy. So it's going to be something like this, where this thing, what is the y-intercept right now? 8. Or 0, 8. Yeah? Then finally I've got plus 1. So what does that mean? To the left, how much? 1. So I'm going to have this point 0, 8 is going to be now like this. What will be the coordinate of this point? If it was 0, 8 here, and now it moves 1 to the left, what will be the coordinate?
-1.
-1 and the y value? 8. If you understand that, then you're sorted.
So doesn't the
I'll just pause here. So there was a question here, where does this right arm, where does it cross? Currently I put it as if it crosses on the negative x, but it could very well be on the right side. It could even go through 0. At this point we don't know. We need to find out the intercept soon, and we already spoke about it. By now you should be quite comfortable finding the intercept. But the most important bit is for you to, I want to see that you understand the process that we got here, okay? So first of all, I'll repeat it quickly again. We start with the mother function y equal x squared. I drew it in green. Then we put that -2, so that does two things. It flips it, it's a sad face, but it also squashes it. Then we added that +8, that means we vertically shifted upward to 0, 8. Then that +1 means we shifted this whole thing 1 to the left, and that's probably, this all is pretty easy, I'm hoping. The only hard bit is this bit that we moved it to the left. So what used to be maximum, okay, this is called maximum. I'm going to use that word. I think I mentioned it last time. We need to start getting comfortable, okay? That maximum point, or your turning point, has shifted 1 to the left, so the new coordinate is -1, 8. Okay? We still need to determine the intercept. I just want to ask you now, are you happy why this thing's moved to the left one? Why is it -1, 8? Are we happy with that? Okay, I'll pause here and we'll move on. Right, so also what I want to do before we move on is just to say that you don't need to draw all these graphs in a test. You don't need to. You can very well, if you're feeling comfortable, do it in your own mind or sketch it somewhere else. What we're interested obviously is just the final one, which is this. Just because we're in class scenario one, I want to see how my brain thinks about it. Okay? Some people might just do everything on the same graph. You can say, okay, this is the mother function, flipped it, shifted it. You can just draw it on top of it if you want, and then move it like that. But obviously it's a bit messy. At the end of the day, that's what I'm after. Now, what Simon said is right. We miss, what 2 points am I missing now? X-intercept. The 2x-intercept, and actually the y. Here it looks like there's no y-intercept, but there is. Just, I didn't draw it properly. There might be a y-intercept thing. But we don't know it. It probably is wrong. If you look at the book, you can see it's wrong. How do we find the y-intercept? Put x equals 0. So y-intercept, okay, means x equals 0. So we put x equals 0 there. So I'm going to say y equal -2, 0 plus 1 squared, plus 8. And if you check that, what do we get? -2 plus 8. I think I'm getting 6. Just check for me. Yeah.
Yes, sir.
Okay. So obviously I was wrong. Well, isn't it? Okay. And Simon already anticipated it. It should be more like this. Okay. How do I know it? Because my intercept is here. My y-intercept is here. So the x-intercept will be one positive. Okay, next thing, I need to find out the x-intercept. So what is 0 in x-intercept? The y is equal to 0. So now it's a little bit more difficult. How do I find y equals 0? I'll just substitute y equals 0. So I'm going to write 0 equal -2 x plus 1 squared plus 8. And I'll just pause here, and what I'd like you to do is think, how do I solve such an equation? Okay, so To solve it, there's a couple of ways. What I wouldn't do, even though you can do it, but what I really recommend you not to do is to open the brackets. Don't open the brackets. You could open the brackets and then solve it. You'll have a normal quadratic equation, which you could use the formula, or you can factorize. You can do that, but that's not necessary, and it's going to take you longer. First thing, you can get rid of a 2 here. If I divide by 2 both sides, you see, because I can take a common factor. And you see, if I divide both sides by 2, I divide everything by 2, then 0 equal minus x plus 1 squared
Divided by 4.
plus 4. Yeah? Now, this should ring bells here. This is almost a difference of a square. Okay? Now, there is 2 ways to do it. I know JD will do it in a different way, but let me tell you first of all how we kind of teach you to do it. What I will do is first of all move to the other side. So say, okay, if it's minus x plus 1 squared, then let's add it to the other one. So it's x plus 1 squared, and then we'll put but basically both add them to the other side, or alternatively multiply everything by minus 1. That's the same thing really. Okay? Now that should really look like a difference of a square, is it not? Because you've got the square of something minus 4 is the square of 2, right? So then we can write, okay, x plus 1 plus 2 and x plus 1 minus 2. Not really sinking in. What is 4? 4 is the square of what? 2. And you see something square minus something square. Okay? That's that formula from grade 9. A squared minus b squared is a plus b times a minus b. And you need to be able to use that. Okay? So now my a is x plus 1. So a plus b times a minus b. That's obviously equal to 0. Okay? That's the same as saying x plus 3 times x minus 1. Okay? Now, I can see you're not very happy with that. I can show you one more way, which we often discourage people doing because it can lead to a little mistake, but I know it's much easier. So what you should do is, let's start with this. Let's go from here. Okay? So I've got this one as a minus. I'll move him to the other side. So I'm going to write x plus 1 squared, and that's equal to 4. I'll keep the number there. Just move that to the other side. So now it's positive, right? JD, what would you do now? You know how to do it. You square root both sides. So if we square root both sides, what you get is x plus 1, because the square root of x1 squared is x1 equal to?
Plus or minus 2.
That's the thing. This is why we don't recommend people doing it, because it's not just plus 2, it could also be minus 2. When you square root of a number, okay, when you're trying to solve that, you need to take both the negative and the positive. And you see the problem. You prefer that one. But you just then must remember that you need to say plus 2 or minus 2. So that leads to 2 equations. Either x plus 1 equal to 2, or x plus 1 equal to minus 2. Yeah, I'll just put. Right, let me just finish and then I'll answer, okay? So I'm going to solve both answers, right? The answer to this solution is basically x equal 1. I just did minus 1. And the answer for this solution, I'll write it above here, is x equal minus 3, right? Which is obviously the same answer if you were going to solve here, okay? If we went this longer way, you again find x equal to minus 3 or x equal to 1. You get the same answer. This is the much quicker way, but you must remember that when you take a square root here, you need to take the positive and the negative. Let's answer questions. Either way you did it, now we should be able to find out what the intercept. What are the intercepts here?
Minus 3 or 1.
Okay, so which one would that be?
1.
Yeah, that obviously is going to be 1, 0, because the x is positive here, where that means that this is minus 3, 0. Okay, so in a test, just so you know, okay, this question will probably be 5 marks. Okay, so you get 1 mark for each one of the intercept, plus 1 mark for the shape, which is a parabola shape. Okay? Yes, I'll pause. So we only did the first part of the question. The question was sketched, and as you can see, that would have been 5 marks probably in a test. The second part in the question B, they're asking us for the equation of the axis of symmetry. What is axis of symmetry? I'll pause and see if I get any answer. Okay, so what is axis of symmetry? So maybe you can call it a line of symmetry. A line of symmetry is, let's put it this way. If I'm a person and I'm completely symmetric, obviously I'm not. You know, my right hand is not exactly the same as the left hand, and you know, we're not completely symmetrical. But let's say we are, then there is a line of symmetry in the middle of us. That if you fold yourself over the line of symmetry, it's the same. You understand what I'm saying? Okay? So obviously there is a line of symmetry here. If I ask you to come to the board, okay, you probably all understand that this is the line of symmetry, right? If I'm folding it here, this arm will just overlap the other arm. So when they're asking for the equation, let me start first of all. Is it going to, this line, is this going to be x equals something or y equals something? What does this line look like? You learn these things in the beginning of grade 9. Y equal are always horizontal line because the y is always the same. Here the y changes all the time. Here the y is equal to 3. Here the y is equal to 6. Here the y is equal to 8. But what is constant? The x. What is the x here? Negative 1. Okay, so it's not y, it's x equal, and it's x equal to negative 1. How do I know that? Because it goes to that point where x is minus 1. Can you see that? I'll pause, make sure you can. So, domain and range. Domain and range, you got to think about archery. So who are we thinking about? Who?
This is
No,
now.
a student.
This is now.
Okay, we're thinking this. Yes, okay. So, right. What are we shooting at? What do we call that area where we shoot? What do we call that? Target? And now, one of these words, which word are we shooting at?
Shooting range.
A range. We're shooting at a range. Okay? So what you're going to think about is like this. Right. Okay? We've got a whole bunch of x's, group numbers that we call them x's, and then they are going to another group of numbers that we call the y. Okay? This is your range. The range of possible y, well, the set of possible y are called the range. The x's, all the possible x, we call the domain. Okay? So a function, okay, I'm going to do that. I'm only doing grade 9, but I'll do it especially for you. A function is a machine. A function is a machine that takes every x and turns it into a y. It's like input and output. It takes a number, crunch it down, boom, shoots it into a y. Okay, I do that in grade. You remember that?
Yes.
Did that, right? It's a machine. Okay, so that's the domain. That's the range. Let's try and find it out. Domain. Domain are basically all the possible x's. Now, normally all x's are possible. Okay, but some function there's x's that can cause a problem. Is there any problem with any x in this function, in this parabola?
No.
Meaning, is there any x that I'm not allowed to put in here? Yeah, it goes on forever. This line will carry on going on forever. I can go all the way to minus infinity x. Same way I can go to plus infinity x. I go anyway. Okay? So there are two ways of writing it. I just want to make sure I use the same as way they do it. Can't really see it now. One way of doing it is just basically say x belong to R.
That's how they run.
Okay, is that what they use?
Yeah.
Okay, that's one way of doing it. That's the way I would do it. Any real number will do. It's fine. Another way you can do it is minus infinity to infinity. Okay, so that means, again, it's the same thing. Any number between minus infinity and infinity, not including, because we can never really reach minus infinity. Are we happy with that? Okay. Range is slightly different here. Range is all the possible y values. Now, should we also say here y belong to R? Are all the y possibles here? No. Which y? Give me an example of y that is not possible.
Because
Give me an example. One example why that is not possible. Y equal? Well, 8 actually is possible. We're just touching it. So there is a y equal 8, but you can't go higher. So give me an example. Y equal 9. 9. Okay? Right? Right? Any y above 8, not including 8, but even 8, 0.0000000000000000001 is not possible. So how are we going to write it? What are the possible values of 8, of y? Y must be
Including 8.
so we can do the brackets business, okay? So we're gonna be including 8, so we're gonna write squared and then negative infinity. Okay, is that the way they did it?
Yes.
Okay, but so then we should write down y belong to.
Well, there's an easier way.
But there is an easier way. I can simply say y is smaller or equal to 8. That's also possible. You can just say y is smaller or equal to 8. So that's including it. Either one of them is possible. Okay, I will pause here. I think we might have done. Let's see. I'm going to say goodbye. Cheerio. Bye-bye. Bye-bye.